Good afternoon, everyone. So, these 2 hours, they are very important because they're going to lead into the first assessment exercise, which I will talk to you about tomorrow. So, that's why I prepared a roadmap because, as I said, in this type of class, sometimes you fall off the wagon because something's not working and then you're paying attention to that, and you can't pay attention to 2 things as a human being. And that's why you need this roadmap. It's a backup. It's already been loaded on Teams. In fact, it's a good idea if you open up this document and put it to one side and follow along, because I'm not going to show you this because I'm going to show you other screens pertaining to ROS. So I'm going to pull this to the side and I'll have it here. So I'll be reading from it, or at least following it, and then you can follow along with your copy. So I've opened up Ubuntu, and the first thing you always have to do, actually you have to do 2 things, is open a terminal window. And then you have to navigate to your workspace. This is your home directory, it is not your workspace. So you go CD, in my case it's the Turtlebot 3_WX. In your case it's the Catkin workspace. So you need to go to the Catkin_workspace, just in ls, and you'll see the directory there. And then don't type it all out, just do a tab complete, because then it picks it up. Okay, and then you source a setup file. This is a different setup file from the bash file. The bash file, deals with the entire terminal, but beyond that, if you want to modify the working environment, then you run the setup file. So it is saved under the devel directory. In fact, you can tab complete that also if you want. So there, see, it picks it up. And then the name of the program to run the setup file is setup.bash. See, it stops there because there are multiple options. Is he a student? No, I know. He's asking me to come there? Or no, outside?
No, I think you want to talk.
No. Okay, so then I tab complete it again, and I run it. So these 2 things you must do, because otherwise it will not recognize certain aspects of your work environment, the Turtlebot 3 and so on. So sometimes when you think a command should work and it says, I don't know what this is, it's because you haven't sourced or ran the setup.bash file. It's very important. So that's the reason. If you go back and source it, then the same command will work. So follow this like a rule book, That's why I wrote it up for you. Okay, then, I'm obviously assuming that the IP address was correct and so on. So if the IP address was not correct, because remember, I have a static IP, but you may have a dynamic IP, so you've got to check the IP with this instruction, if config. And then the IP address is over here, right here. And if it is different, you have to copy it into 2 places, right? One is the bash file. So you gedit the home /bashrc file, and you modify the old IP address with the new one. And then you lost connectivity? Okay, that's right. You just wait till they get connected.
Don't do anything. Your monitors will come back on.
When I started computer systems.
So while we are waiting,
Yeah, everything is back on.
oh, we're back on?
Yeah.
Oh, okay. All right. So, again, if you have any questions, raise your hand. If anybody is thinking about dinner, it's too early. You need to focus on this. So, what I was saying was that the IP address has to be copied into two places in the bash file and also in the MATLAB program. Remember, the MATLAB program also needs that. So, actually, a change in the bash file in 2 lines and then one place in the MATLAB file. Okay. Now we're going to launch the gazebo simulator, and you can tap some, complete your way to finding the right launch file. It's the empty world launch, but I believe I was working with it earlier today. Hopefully, yeah, there it is. So you can cycle up, find it, and run it. So we don't need this window. Don't close this window. Don't Control-C out of it, because this process has to be live so long as you want gazebo. So just minimize it. So a quick word about coordinate frames. We'll get into it later this week in greater detail. But you see the colors here, they are there for a purpose. This is the standard robotics notation. So what you're seeing is the world axis. So anytime you work with a robot, right, you have to define a world axis. And there can be only one world axis. So you cannot have a world axis here and then you have another world axis in Chennai. If you have a single robot, then you can have only one world axis. So that world axis is fixed. It's like somebody planted something in the ground. It's not movable. Now, the robot will have its own multiple axes. Now, why multiple? Because the robot itself, right, needs a reference coordinate frame. The same thing, 3 axes. But that axis is not fixed because the robot is going to move. The world cannot move. Is that clear? So you'll see that there are multiple axes, sometimes 17, 18 axes possible. Now, I only mentioned 2. How did I get to 17? It's because you could have multiple cameras on the robot. Maybe the cameras are fixed, but cameras fixed only means that their coordinate axis is fixed with respect to the robot frame. But the robot itself is moving, so the camera axis will be moving with respect to the world frame. Do you get that? Also, each of the 2 wheels has an axis. The LiDAR, wherever you mount the LiDAR, that has a 3-axis system, which I call the axis. So, you might mount a camera on the wall of your lab. That camera has to have its own frame of reference called an axis. So, what you're looking at is the world axis here. Now, red is the x-axis direction. That's the convention. It's always through the nose of the robot pointing forward. So red is the x-axis. Green is the y-axis. It's always to the left, not to the right. It's not take your choice. The robot convention has nailed it down. Left is y-axis. The z-axis is pointing up, not down. Now this is known as a right-handed coordinate system. It's called a right-handed coordinate system because if you take a right-handed screw and turn the x into the y, then the screwdriver, the screw tip has to advance in the direction of the z-axis. That's why it's called a right-handed system. Some people use left-handed systems, but they're outside the robotics community because if you want to work in robotics with other people, then you have to go with the right-handed system. So turn the red axis into the green axis and your screw tip will come up. So that has to be the z-axis. Otherwise you can use, some people use this rule. They this part of your fingers is pointing from the red to the green, and your thumb is pointing up. Is that okay? So X into Y should give you Z. Alright, now, the robot has its own axis. How come it's not showing up? You make it show up. See, I moved to this one here, and can you see it? We can zoom in. I don't want to go to zoom and all that right now. I'm going to show you how to use a 3-button mouse. You can't use a touchpad, it won't be very effective. You need a mouse. So, I know you are from the younger generation, but you need to get a mouse. A touchpad it doesn't work very well with Gazebo. It will work, but it's very complicated to do it with a touchpad. Okay, now, I'm going to go back here. So is everyone clear that this is what you're going to see? Alright, now I'm going to go back to the map. So, we're going to learn how to read odometry. So odometry it's the odometer, which is a sensor, is counting the fractional rotations of the wheel. Now how does it do that? It's because they have an optical disc with alternate black and white sectors. And essentially they're shining light from one side and picking it up on the other side. So imagine if you put 1,000 black and white sectors around an optical disc, right? As the wheel spins, you'll get pulses on the other side. So they are not just measuring the full rotation, they are measuring 1,000th of a rotation. Now if you are not happy with that, you can go to a 10,000 count encoder. After a certain point, you're wasting processing power because it makes no sense to know the rotation of the wheel to 1/10,000th. Because there are so many other things that are interfering, like noise, slipping, sliding, that it makes no sense to measure anything at that level. So in any engineering experiment, you only measure to the accuracy that makes sense. Okay, now, so odometry needs to be reported because odometry is the most fundamental way of locating where the robot is, localizing the robot. So localization in the context of a robot moving on a plane is 3 numbers. X, Y, and the orientation, known as heading. So X, Y, theta, the theta is known as the heading. When you're moving on a plane, you only need 3 numbers, right, for the robot. How about a drone moving in 3 dimensions? You're going to need 6 numbers. X, Y, Z, and 3 angles. Does that make sense? So if you have a robot doing surgery, then definitely you need 6 numbers. But most of the time in robotics, we start with robots moving on a plane because you always start with something that's simple and then you extend it to more complicated scenarios. So these 3 numbers constitute odometry, and you're going to see the odometry results as we move the robot. They're actually going to see it. So let's read the odometry. So if you're looking at my roadmap, it says read the odometry once only. This command, in particular the -N1, is designed to echo to the screen. Echo means echo to the monitor, the display. That's what it means. ROS topic echo. So it's saying echo the values of this particular ROS topic. Remember yesterday we talked about topics? Right? Remember topics? That's the way you communicate. It's like a bulletin board. The odometry, whatever the package is posting information to the bulletin board. That's the topic. Now we want the topic printed on the screen because we want to see it, right? And that's how it is done. Echo means, put on the display. And -N1 says do it only once. Because there is another form of the command which says do it at 10 hertz, meaning 10 times a second, or 100 hertz. It's not worth it doing that, because if you have 100 sets of numbers, by the way, you will see a lot of other information apart from X, Y, and Z. And if you see 100 of those every second, a human being is not capable of making sense of 100 numbers running off the screen. So typically when you echo to the monitor, you echo it at a very slow rate or you echo it just once and stop, get out of the program. When you echo it at 100 hertz, right, you will not get back control from that particular terminal window because it's doing it. You can ask it to echo continuously as the robot moves, but who amongst us has the ability to look at the odometry and say, oh yeah, I can read those 3 numbers from a sea of numbers? We can't. So we're going to open a new window. Now you know why we need to open a new window, right? Because the gazebo window is already occupied. You can't do anything there right now. So you need to open a new terminal window. That is the old terminal window. So I use a new tab. There it is. And then you type ROS topic. Oh, why didn't it complete? Oh, because there are multiple options. Okay. Echo minus N1. I don't know whether it's going to complete that. And then you need the odometric topic. Now, I know it's O down, / O down. I'm going to tell you later, how did I know? Because in a Ubuntu terminal, if you hit ROS topic list, it will give you all the topics that this particular robot is associated with. And then you go to the ROS.org webpage or some other Google generated search page, you can figure out what all these topics mean. I have done all that for you because I worked on this for 12 years now. So I've done all that. I know / ODOM is the odometric topic. So you can take it from me. Okay, so then I hit return. See? For 3 numbers, we're getting all these other numbers, right? So if you keep printing this on the screen, it's you will never be able to keep up with it. Even you, being much older than me. So, we go up here and see what's going on. There's the command, right? Now notice, there's 2 sets of numbers. There's something called twist. And there's something called pose. So pose is the name used in robotics for the localization information. Pose. That means it's made up of what? Essentially it gives you the 3 numbers, right? But we see more than 3 numbers here. We see 7 numbers. And it's divided into position and orientation. Now, I told you that when the robot is moving in a flat plane, only 3 XY is needed, Z is not needed. But it's designed to report Z because you can also run drones in Gazebo. So it's reporting Z, and notice it's a very small value because the center of the robot whose pose is being reported is not on the ground. It's slightly above the ground. Do you understand? Because the wheels are there, right? So the robot center is slightly above ground. You had a question?
So it says Moron does not appear to be published yet.
Did you launch Gazebo?
Yeah, I have to launch this video.
So, no, you should launch Gazebo. So ROS core is not there. Okay, can you open another terminal window and say ROS topic space list? Is anybody able to see or down? A new terminal. Yeah. It should give these kind of numbers. You get it?
Position orientation.
Yeah, right. So how come? The size of the window? Yeah. Is it better?
And then you want to zoom in? Yeah, very zoom in. I think I can zoom in. Yeah.
Yeah. It's getting a little bit better.
Zoom in as much as possible.
Yeah.
Maximize it.
Okay. Okay. So, as I was saying, how come 7 numbers? I said only 3. It's because position, right? They are picking up the Z, even though it's 0 or very close to 0, because it's the robot reference point is not on the ground. It's slightly above where the axis is centered. Okay. Now, what are these numbers? So, normally you would expect a single heading angle, right? But there are 4 numbers. It's because angles are very troublesome in robotics. See, angles have this problem that when you go all the way around, you get back the same value, right? So in other words, 370 degrees is the same as 10 degrees, right? So angles have this problem. There's also another problem known as gimbal lock. In 3 dimensions, you can get the situation of gimbal lock, G-Y-M-B-A-L, lock. Tonight, if you have a few spare minutes, you can Google Apollo 13, gimbal lock. So Apollo 13 had a major problem with gimbal lock. They never anticipated it, and now of course looking back you can say, how could they be so stupid? But obviously, Apollo 13 was in the mid-70s, so all scientific inventions, when you look back, will appear foolish. How come they didn't get this? That's because we have the benefit of hindsight. So gimbal lock is a problem with angles, and therefore you have to solve it. And it's solved by using the quaternion representation. The quaternion representation avoids gimbal lock completely, plus this problem of where the angle comes back and so angle is not like distance. Distance can go to infinity and minus infinity, right? But angles end at 360 and they come back around, and that causes a problem. So I'm not giving you all the details. Obviously that takes much more time than we have in this class. So you have to accept it from me that quaternion representation is needed. Now, what is quaternion representation? It's made up of 4 numbers. Now, the numbers you see are X, Y, Z, W, and they're going to get confused. You're going to say, is this X, Y, Z the same as that X, Y, Z? It isn't. It is the first 3 numbers of the quaternion representation. W is the last of the 4. So even though they should not have used X, Y, Z, but these are, Ross guys. They understand it, so they don't care, whether you understand it or not. So X, Y, Z, W is a quaternion represent, nothing to do with the X, Y, Z coordinates. I will tell you, maybe early next week you don't have any classes because you have something else going on. But when we get to coordinate transformations, we'll get into quaternions. Okay, now, so don't worry about the covariance, but I think we should look at this part. So, twist is the name given by the robotics guys to this pair of commands, V and omega. Remember I said that robots are commanded by V and omega pair? So that is called the twist command. So when you say twist command, you mean a V and omega. That's how you typically command robots. T-W-I-S-T. And right now, it's saying that the velocity of the robot in its own x direction. Now notice this, right? It has to be in its own direction. Because if you are running and somebody says your velocity with respect to the world axis is such and such, you'll say, okay, I don't know what it means, right? Because if you turn, that's going to change. So everybody wants to know their velocity with respect to their own axis, right? You can imagine an axis embedded in your stomach. That's what the robot axis is. So the robot's x-axis velocity is basically 0, 10 to the minus 8. The velocity in the y direction is 10 to the minus 7. Now why both of them are not dead 0, I don't know. It's based on how they calculate and write the software, but they are very, very small. The velocity in the z direction is definitely 0, it says. It's not flying up this way. Okay, now the angular velocity. X and y don't matter. Because x, right? X is the rotational velocity. See, the robot's, the red axis is like this, right? So that's what they're talking about. Now, how can the robot rotate like this when its wheels are on the ground? A drone can do that, right? So if you simulate a drone, all of those numbers will be active. So x is 0, y is 0, because the robot is not falling over or falling forward. So z is the only thing that matters when your robot is on a plane. That's it. It is not in degrees per second. It is in radians per second. Radians is the scientific unit. Degrees is for our convenience. Why 360 degrees in a circle, right? Why 12 inches in a foot? I think it was King George or somebody who just said 12 inches in a foot. Am I right? 3 feet in a yard. They just made it up, basically. Yeah, right. But I'm saying, like 100 makes more sense. And yet, England ruled the world and they dictated how many inches they were in a foot. Alright, so that's the nature of this. So notice that it is giving you the correct odometry. But you know what? We're going to move it away by using the joystick command. And then we're going to come back and read odometry again to see whether it's telling the truth or is it lying. So, I am on item number 4 now. I'm going to move the robot around using the keyboard. So I need to open a new window again. So, no, I don't, but I want to keep the odom window as it is. So even though this is complete, I don't want to use it right now. So I'm going to open another window and I'm going to run the joystick program. You can cut and paste from my document, or you can tap complete, ROS launch, TurtleBot 3, and then teleop. So that's the package directory name, and the last part is the actual program name, and that is TurtleBot. TurtleBot. There's only one possibility, so it completes it. Has everybody got here? New window. Okay? Now, so this is always the problem when you teach robotics anywhere. In the US here, you don't have enough screen space. So in my own home, I have 2 big monitors next to my computer, and even that's not enough. So I have a 60-inch TV, which, do you have a smart TV wherever you're living? Because if you're going to put the software on your computers and you have an HDMI cable, you can use your smart TV as an extra monitor. You're going to need that because otherwise windows are going to fall on Windows and you'll have to resize it or minimize it, and it gets very irritating. So first let's read this. So the maximum speed of the TurtleBot 3 is 0.22 meters per second. The manufacturers say that. Now I have found that may be true of the actual hardware robot, but in Gazebo, I'm able to run it at 0.4 and it runs 0.4 meters per second. This is one of the reasons I don't like the TurtleBot 3 as much as the TurtleBot 2. The TurtleBot 2 could go at 0.65 meters per second. Now you're saying, what is the difference, Where is he going in a hurry, right? Here's the thing, when you simulate on Gazebo, those squares are 1 meter by 1 meter. So if your robot is going to be slow, you'll have to bring your obstacles and all that in, because you don't want to wait 1 minute for the robot to finish the exercise. Because if you make a mistake, now again you bring it back and run it again, right? So if the TurtleBot or any robot is going to be that slow, you're forced to create a very small scene. You can't make it big because it's going to take time. So reruns take time. Now, of course, it's still better than taking the actual robot outside or inside, and running it. But I would like a faster robot. They actually made the robots weaker in terms of torque on this. I don't know why, maybe it was a cost factor. So, 0.22. So look at this pattern here. So this is how you make it move around. A is, AD, increase, decrease, angular velocity. A is increase, D is decrease, right? And W is increase, decrease, linear velocity. And he says for the burger it's 0.22. The rotational rate, the highest value is for the burger 2.84 radians per second. Is that clear? So, space key will stop it, or there's key. So try to move it away from the origin, move it to 2 or 3 meters away so that by looking at it, you know that you can read its odometry, human odometry. You just look at it and say, okay, that makes sense. Are you able to move the robot? So by the way, when you move it, the focus has to be on this window. You cannot be here and try to hit those keys. It won't work. Is everyone understanding that? When you want to use this program, the focus has to be here. So yeah, it's a bit of a gymnastic thing. You have to minimize it, move it out of the way so that you at least see a little bit of the turtle board. That's what I'm trying now. So that's good enough. I come back here. I have to come back here and click. And then I can try to move it. Let's see if it moves. Okay, let's do a W. It seems to be moving quite slow. See, that's what I said. It's very slow because you haven't even got up to 0.22. Then I do a little bit of a turn. And then it goes forward, decrease. Oh, I don't want it to go back. Anyway, get it to a point where it is away. Oh, now I like it. Let it go a little bit further, And then I'm going to stop it like that. So get it away so that there's no confusion. Now, even a human being can say, what do you think the coordinates are? Don't worry about the angle because I have to get into quaternions to explain that. So we're not going to read the quaternions. The quaternion. Remember the 4 numbers? We're just going to read X and Y and confirm that it's kind of working. So I think the X is about 2. Do you agree? I can't read it any more accurately than that. It's about, see, this is 1, 2. And the Y is, no, I don't like that. I don't like X and Y to be the same. So I'm going to move it a little bit further. So again, I come back here and maybe go forward. Maybe turn a little bit. And then go forward. And stop it. It still ended up with X and Y about the same, but you get the point. You want X and Y to be different so that you recognize it's correct. So what do you think we're going to do now? We're going to go back to the odometry window, which has stopped running, but I can just cycle back and run the same command. Let's look at not the twist, but the pose. So X is 2.82 with my robot. 2.8, yeah, that's okay, right? Close enough. And Y is 2.43. So you think it's okay? Everyone? Right? Now, the orientation, we'll get to that later, I said, because the orientation is a little bit more difficult. So, if you had run the odometry constantly, right? Constantly meaning, you never want to run it at 100 samples per second. You'll never pick it up. No human being is going to pick up that. But if you had run it at, say, 10 hertz, you would be able to see the velocity change here. So the velocity change you can actually see. If you can pick up numbers on the screen, you could have seen the velocity change and reported by odometry. Is that okay? You could also have seen the X and Y change dynamically. I thought that was not needed, but you can. I don't think 10,000 numbers on the screen is a good way for a human being to interact with a computer. That's the biggest weakness of a human being. Is everyone happy with this? Are we all at this point? No? I'll give you some time. You can back up if something has happened and try it again. So if you don't get this, we're not going home. We're going to be, right? We're going to be all night if you don't get this. Yeah. You got it? So you'll get used to the controls. It's not easy, When you hit turn, so turn is continuous. You want it to turn and stop turning, but then it turns and starts going back. You don't want that. You've got to get used to the keys. You can tell I haven't got used to the keys after so many years, because I don't use that very often. It's nice to have a joystick. You can do that too. You can connect a joystick and run and move that. So we'll pause for 2 minutes or 3 minutes and let everybody catch up. Arms and all that. Yeah, not like this. It's so bright, Somebody should set up an experiment like this and just like a dry dictionary. People go to it, and they don't grasp it, they never do it. I don't know what you're talking about. Then you have to say, see, right there. So you can go to something without really being into it. So, see, those guys know it so well, they are not able to relate to somebody who does not know anything about it. Yeah. It's just kind of losing. Yeah. Exactly. You don't give you a feeling for what you're doing, right? Yeah. Everyone got it? So, let me summarize what we did. We opened up gazebo, and then we learned how to echo the ODOM topic to the monitor. So initially it was all zeros. Then we opened up the teleop joystick program and moved the robot away from its initial position. Then we stopped it. We ran the echo program, cross topic echo ODOM again, and we compared with where we think it was, where we think the robot is. So it's like we close the loop and we understand what ODOM is doing. That's it. Is it okay? Okay, so we finished 5. Now, I'm going to teach you something that we may not use from the Ubuntu end. We're going to use the equivalent of number 6, what we're doing in number 6 from MATLAB. It's the same thing. MATLAB allows access to all of this from the MATLAB side. So there is a way of just launching Gazebo and then going to MATLAB and never looking at Ubuntu again. You can completely be in MATLAB if it's comfortable with, for you. Once in a while you may have to go to the Ubuntu side. But the experts, they stay on Ubuntu side. Maybe they don't even use MATLAB, they may use Python. But I like MATLAB. So, what is this raw service called? Second bullet under 6. Raw service called Gazebo set model state. Now, when you're running a homework assignment or any task, right? You may not, what is the default position of the robot on launch? It's right at the origin of the world frame. You may want to put it at 10:9, right? 10,9, 10 meters, 9 meters, and then you may also want to give it an orientation. You may want it to point at 45 degrees. So this raw service call allows you to do that. So, I have set it up to bring the robot back to the starting position. But after that, we'll try to put it at, say, 3,5. Okay, first we'll bring it back to the starting position. So, we're going to run this. Are there any windows available? But I don't think we're going to use the odometry window again. So, maybe I can use this. Yeah, I can use this. And then I copy the command next to the second bullet, raw service So these are services written up in ROS. You know, somebody has done it for us for our convenience. Call, and then try hitting tab complete. It picks it up. Gazebo slash set model. Okay, there it is. And then state. Okay, at that point, hit tab. And a whole bunch of things open up. Now, you have to be very careful how you deal with this. When you hit that last tab, right, it opens up the entire form. So this is a raw service that positions objects. It's not only the robot. You can move an obstacle to a certain location. Right? You may not want the obstacles in their default locations. You may want to move it to create an obstacle course at the beginning of your program. Is that clear? Right now we are using it for the robot. So because we want the robot moved and not some obstacle, first of all there's no obstacles in this, it's an empty word. But if there were obstacles and a robot, you have to tell it which one you want moved. If you just run it like this, it will say, I don't know what you're talking about. So there are two things to complete. So for instance here, right? See these codes here? So you're supposed to fill in the reference frame. It's asking you, you want it to be moved, but with respect to which reference frame? Remember I told you there could be 17 reference frames? So it wants to know which reference frame are you talking about when you're giving me these coordinates. So you have to put word. I don't know whether tab complete works with this form entry, so I just typed it out. Word. Oops. Word. Okay? They're not done, so don't hit enter. So put word. Now another important thing. This form is not like a sheet of paper. You cannot go up down. You cannot go up down. So don't use your up arrow or down arrow. It will take you completely out. Only left right arrows work. It is linear. All of this what you see here is not an image. It's not pixels. So you can only go left and right. So you have to cycle left, cycle left. I'm not interested in changing anything in the twist part. So I keep going. You have to be patient. I don't know the orientation right now because I don't understand quaternions, right? So I'm going to skip right past the quaternions. This is where you put in the 30 degrees or whatever orientation you want the robot to have. Originally it was 0 degrees by default, but you can do 45 degrees provided we figure out quaternions. So I keep going. You know what will happen if I put a Z value? The robot will actually move into the air. And then, gazebo has gravity built in. It will then drop. Once you say, okay, gravity will pull it down and it will bounce. All those are picked up by the physics engine that they're using. So funny things will happen. You can toss the robot up in the air and it will fall and all kinds of things will happen. Okay, now here, why do we do this? We will move it to 2, 4, not back to the origin. So we move it to 2 and 4. Is that okay? So I don't want it to go back to the origin. I'm taking it to 2, 4. Did you see what I did? Only left, right arrows. Right now, left arrows because we're starting from the end. And then you have to put in the model name. I know this is a bit of a hassle. Left arrowing your way all over. So over there, what is the model name? So this Turtlebot 3 has a special name, and if you're wondering, how did this guy memorize it? It's right here. Right here, see? Where is it? Yeah, here. No, that's not it. Oh, I can't see. This is Turtlebot 3 burger, right? So that's what it is. See? It's in a color that my eyes are having trouble with, but there it is. Turtle bot tree burger. So that's how we know. All the models, their names will be listed there. So I'll go back and I will first get back focus here and then turtle bot, turtle bot 3, what was it? Underscore burger. Underscore burger. I hope I got it right. There should be no spaces or, yeah, there isn't. So, burger underscore turtle bot. I think missing a T. You didn't tell me. Now, you don't have to go back to the end of the command to hit enter. You can hit it right here, I think. Watch. 2-4, right? I hope it works and I don't get an error, but I think I did it right. See what happened? You missed it. The robot moved to 2-4, right? The orientation is, we didn't do anything to the quaternion, so it's all 0, 0, 0, that corresponds to 0 degrees. Take it from me, later on we'll figure out why. So here is the robot. Try it. I'll give you a few minutes. So when you have created a course in Gazebo, it's a problem you're working on, and then you shut down for the day. Of course, you don't have to shut down the computer, you can leave it on, but some people prefer to shut it down. One thing is you can save your Gazebo world, that's one way of doing it. The other way is, if you have all the commands that position the obstacles and the robot to the right positions, you can run that at the beginning of the next day, and automatically everything sets up. Otherwise, if you move 15 obstacles, if you bring down obstacles and you put it here, then it's a lot of work to arrange the scene. Has everyone got this? Well, you know? Is there a problem? You want me to go through the command?
Yes.
Okay. Alright. Okay, yeah, I got back the prompt. So I'm going to run the same command again. No, I don't like that. It gives me the whole thing. So let me run the command from the beginning. So ROS service. Okay. And then what was the next one? Call / gazebo / set model. So basically we are telling it we want the model to be in this state. That's why it's called set model state. State, right? I'm missing my place here, so that's why. Yeah, set model state, and then after that, hit the tab. Huh? Oh, because I'm not focused here. Something's missing. I've lost, I don't know why I lost. Hope it's my scratch. What do you mean? I think I scratched it. Okay. Yeah, I think we've got. But this one doesn't work, so let me try it again. I'm not getting any, so I'll close this window. I've lost something in this window. I can't type in this window at all. So I don't know why that is so. See, even the So I may have crashed. Let me come back. Yeah, crash report is ready and I will send it to website. Alright, so I'll get out of gazebo also, okay?
That's why we have the
Yeah, right. This one? Yeah. So let's get completely out. Yeah. So once in a while this happens. It's happening much less frequently than in the early days, but I think there's something happened that it could not authenticate me for some reason. It's asking for my password again, and it's not taking it. Yeah, and lots of things. So you got to get out and come back. Come back. Sorry. Doesn't take my password. No. Somebody has to boot up again. Okay, something happened. I got to boot up again. Maybe a virus attack. First time in the Mac. I know. Mac is losing its reliability. They don't want to because of the rush, right? The rush to market. Because the iPhones heat up, what is an iPhone? They're heating up. And suddenly running things on its own. I use the password. Sometimes I leave it people, they just don't use password. Yeah, even the Mac has a password. Okay. right. Yeah, right. Yeah. So it becomes like a language almost, like a human language. Yeah. Okay, everyone?
Yes.
So raw service call, right?
Yes.
I'm putting up the same document here. 1 second. So service call / gazebo, and then / again set model state. Okay, at this point you hit tab complete, right? It opens up the entire form. Back up with your left arrow and put word here. Okay?
This is a model study. Sir,
Huh?
what happened?
So put word there. Tab is not working. So after model state, you hit a tab and you're not getting any of this. So that must be, I don't know why. Why would tab complete not work? So for nobody it's working? So there's something missing in the software? But you're able to tab complete up to this point.
Yes, till state we did, and after we are hitting the tab, it's not working.
Sir, can I see the command?
Here, so the command looks like this: raw service call / the zero set model state, then use tab complete. See what terminal? You mean this one? What do you want me to do? Is it / / the zero / set. So did you spell it properly before, or you trying to tab complete up to that point, or are you spelling it?
Command is
But the first part of the command must be correct. Did you tab complete the first part of the command, or did you try to type it?
We type it.
If there is a error, no, I agree that everybody can't be making the same error, but why don't you try copying from my document and pasting up to the last tab complete? Because tab complete ensures that the command is recognized. That's how I did it. But if you're going to type it, it's likely that, so make sure it's / and not backslash. You know how you tell / and backslash? So that forward leaning like this, right? That's supposed to be /. This is backslash. Got it?
Yeah, we did.
/ backslash. So I think maybe all of you are interpreting the / as a backslash. So does it complete up to that point? So it's not completing at all.
No.
Okay, so I think that that some software is not installed. Yeah. Some gazebo, this is a gazebo piece of software. So all the gazebo stuff is in the simulation tab. Oh, the last code is not running? Yeah, so that comes from the gazebo, so I'll show you where that is, right? So the whole MathWorks package is wrong, right? Because, here, for instance, narrative, and then you have to go to simulation, and then gazebo simulation, and it tells you that you have to load something. Yeah. So here, see, on the robotics page, right? You go to simulation. All the gazebo stuff is here. It's called simulation cycle. So diplom, CDD, and then capital name. And then so that part seems to be missing.
Casting days might take long time.
Oh, really?
Packages are there and the environment that's distributed.
What about it? You follow this? Install simulation cycle? Because,
No, this came along with us. So we really have to.
oh, I see. You can try double installing this.
This is the company name, package, where package.
Right.
You install everything, use the parameters and environment and then. First topic is
So no part of it is completing, right? None of the command.
See, your set model state is running. Set model state is running. That is running.
Okay.
Set model state is running. Set model state is running.
row service column and working row service code command working argument row service type row service type row service type row service type type space but space
So am I correct in my understanding that you can't get any part of it to tab complete? So we say raw service CA, tab complete, nothing. Okay, so some software is missing. Doing another Captain May code, say that takes too long. Yeah, it takes too long for Captain May. Get out of all this gazebo.
We tried it on bugs.
Yeah. Right.
Makes no sense. This takes too long to this.
The other thing is I have like 2 steps to go to finish the part 1. I was going to do part 2 also, but then obviously we cannot. But at least they'll have the picture and then they know which ones they could not do. And once we fix it, they can try it. So let him try that cat and see what happens. So the MATLAB package, so we installed the MATLAB package in our labs. Only I did the separate installation. And the students never said that, it's not happening, like completely said. So they were able to, in my university, we did exactly this. We took the MathWorks package and it worked completely. Yeah. Windows. Yeah, the lab computers are Windows. Yeah. It was too fast. Yeah. Yeah. So I don't know what's going on here. So I can move to Gazebo and show them some other things, and then we can tackle this. This is not very important because we're going to do it from MATLAB settings. Yeah. So, but if this is missing on the Ubuntu side, MATLAB might not find it also. So is there a way of doing a raw service list? Just like raw traffic list, Oh, you said the set point state is running. So why they not able to call it? So if you list, the services, if the service is running, then why are you not able to call it, right? That's really strange. Maybe it's not able to locate that. Is it working?
Yeah, the raw services.
Yeah. Did you break it? Did you break it?
Sorry?
Did you break it? He says it's working.
See, this night, service call not working.
Call aren't given. Roll service.
You can try the same thing.
Right? Yes, it's I'm just stay there 2 minutes and then there's one at this point. Yeah. You can sit down. That's good. This one. Seems raw service is working, raw service call is working. So then I can't call anything from the receiver.
From the terminal window.
I'm not able to call anything from the gazebo.
What do you
I
mean
can
by
call it from the
gazebo?
gazebo.
You have to run it from a ROS terminal window, right?
Yeah.
You do a gazebo call, gazebo service call from the ROS window, though.
Last window.
What? You got it? How do you do it? Because when you say you still have to call it from the ROS window, the gazebo window is occupied because it's running the gazebo, right? So how can they type anything in the gazebo window? Maybe that's what they're doing, they're typing in the gazebo window? Or you type in the ROS terminal?
Can you show the screen like what is what
So now we're getting all this?
Yes, sir.
Yeah. So then you go here, put word here.
Sir, we can call with the echo, rostopik echo, the gazebo model state is without row service call.
Allah, he wants to set the parameters.
But I want to set it. Echo is passive, I'm receiving.
You want to set it?
Yeah. So call is you're calling the service.
Yeah, I can, raw service is working, I can do a raw call, raw service call. But then I only call gazebo GUI node. I cannot call the gazebo node. Nothing in the gazebo node. Whenever I try to call something in the gazebo node, it says,
But it does list the service.
yeah.
So
I don't know why that is.
is that like an IP connectivity issue or why it's not able to call? Internally it uses IP for everything.
Yeah, because it's running on the same machine. There shouldn't be an IP issue.
Right, but I think the way it communicates is IP based even inside the computer. But that all that is hidden. So somebody who's not occupied in trying to fix it, can you try this command and let me know if it works? This one. So open a new terminal, try raw stopping pub minus R10, no space. I don't think there's any space there, or is there? Let's see. Yeah, there is a space, minus R10. Command underscore well space geometry message. So tab complete. See if this tab complete works. Raw topic pub, then minus R space 10, and then you try to tab complete through this. Up till here.
Sir, okay, I understand that. Sir, no, you need the service arguments for that also. So
For this one?
no, the one, yeah, that one. Set model state.
Yeah.
We need the service arguments also. So I think the cross call will.
It's not. It's not opening up the form.
No.
So that feature is not there, but we are all running cross noetic. So
Yeah.
here, which one are you talking about? This one? No, this part you can't tab. If you tab, you get a form and you have to enter the numbers. You get a big form, but this is a short form of that. So you are able to do this, and you get a form. At least you can finish this part. Right. And those service arguments I'm filling out by tabbing and getting it to open up the form. Yeah. So we don't know how to put those service arguments, right? Because it's not telling us in that note how exactly to put this. But maybe there's a form, curly brackets or something. If we figure that out, we can bypass this.
Maybe I'll put model state in there.
Yeah. And then we have to figure out how, so for instance, that's how this is done. See this one I was showing them?
Right.
Here, see, it tells you that this is if you don't want to open up the form, then do it like this. But we don't need to know this format then.
Right. But can I use the same form as that?
How do you put the turtle body verb and reference frame? Like comma, and right? Remember, there are many that we skipped, right? Remember, there are many that we skipped. We are defaulting those. So is this command working? No. You're not able to enter this and nothing happens.
No.
So you don't have this command well topic. When you list ROS topic list in a terminal, does it list cmd underscore well? So for instance, gazebo set model state, CMD well. So the service is running. At least it's running on my computer. It's running there too, right?
Which one?
Yeah. Gazebo set model state. Here it is. So,
Yeah, that is running.
but you're not able to call it.
Even the raw service is running.
Yeah.
What I need is the service arguments. If I have the service arguments,
So
the
let's say
service arguments are not auto-populating. Okay. Let's see the flash table.
yeah, it doesn't tell us exactly how to enter the service argument. YAML, see, raw service find that. Raw service this, raw service this, raw service. Type. Oh, yeah. Service name, service argument. So how do we put in the service arguments if it's not opening up a form? That's the question.
Yeah, that's fine. Yeah.
Yeah.
So we do need those.
See, example, raw service call / add to integers 1 and 2. So
Right.
there it's clear. But here we have a whole form and we're skipping some of them and only entering 2.
Yeah. So we need what, 7 variables?
It's,
We have 9.
yeah, but who knows what the format is, you know?
We could try typing those in. Yeah, but then that's not going to work.
Yeah, why don't we skip past this and go to one other thing that I want to show you and then we'll fix this later. Okay, so that was unexpected, but let's get past it for now. So what I was going to do was the following, you know, I was going to run the robot in a circle, and the way to do that is this command. Apparently that can't also be tab completed, so we got to fix that. But essentially I'm publishing at a rate of 10 hertz, 10 times a second. Why? Because all motors and motor-based robots, they're supposed to have a feature known as a watchdog timer. And what it does is, if you do not repeat the command, it will by default shut down. So you have to repeat the command. If you don't, it will shut down. Why do you think that's the case? Why do they have that? Huh? No, it's much more drastic. It's very important for safety. So for instance, if you have a driver of an electric train, right? And he's leaning on the, whatever they call it, gas pedal or the equivalent. So if he has a heart attack, right? What happens? The lever is released, you know, they assume that he won't fall on the lever, which I guess they have a way of preventing that. But he falls away and the train comes to a stop, right? All industrial motors particularly are supposed to have that. If it doesn't get, so basically if I'm the driver, people should tell me keep driving, keep driving. The moment I don't hear this tap, I'm supposed to stop. All motors are supposed to have it. Now, Turtlebot 3 has not programmed that feature into their robot. Other robots have. So ClearPath Robotics, another company, their robots, the moment you stop commanding it, it will come to a stop. Here, all you're doing when you stop the command, right? So suppose I publish this, you know what's going to happen? It will run forever. Even if I stop publishing, you know what I mean by stop publishing, right? I hit a Control C. And that means you're not publishing to the topic anymore. There's no connection between the bulletin board and the robot. The robot has already grabbed it, and if you're not giving it new values, it's going to run with the last value. So that's a bug. You know, they should really have fixed it. Nobody has complained, so they didn't care. So we'll have this strange situation where it'll move in a circle, but when you interrupt this command, it will continue to run in the circle. So you know how to stop it? I'll show you how to stop it in MATLAB in the next class. But how to stop it from Ubuntu? You repeat this command, but this time you put 0 here and 0 here. So of course, all that depends on this command working. So first thing is, you run this command and get it working. And it'll go in a circle, you know? Why is it going in a circle? Because this is the forward velocity, 0.3. No side velocity, right? You can't give this robot a side velocity. It's not capable of moving sideways. Definitely it's not going to fly upwards. It's not going to rotate about the x-axis because that means the robot is falling over. It's not going to rotate about the y-axis. Got it? It's only going to rotate about the z-axis. And I've set it to rotate at 0.15 radians per second. So which means that 0.3 divided by 0.15, the circle will have radius 2 meters. So let me show you that. So anyway, I showed you this, but there's no point since it's not working. Essentially, when it works, what you're supposed to do is put in world here, or word frame, and then put in the model name, turtlebot 3 underscore whatever, gazebo whatever. You know, I forget. We put it in there, and it zeroes out the velocity. I'm sorry, it zeroes out the position. Okay, so I'm going to Control C my way out of this and use the same terminal. And I'm going to say ROS topic pub minus R. It looks like a space. Yeah, I think there's a space. And then, so it, you know, at least it's working with me. The tab control, tab complete is working. And then, okay, that's working too. Now, this is the short way of doing it. But in my case, I'm going to show you the long form also. So if I don't want the short form, you see here? You see this? So this form will open up. Right now, nothing is opening up for you, I know. So what do you do with this? You go back here. And then you go back some more. Exactly the same as the raw service, the previous one. Oh, see what happened? Somehow I touched. Oh, there it is. I'll show you all this next class. The perspective, you know, changing the perspective. It ran away somewhere. It's basically lost control. So I don't know why that happened. So first I'm going to zero it out. I have to stop it first. Okay, I brought it back. Let's try it one more time. I don't know why it tilted and went into a crazy loop. something is wrong. I think the velocity is too high for it. So notice if I control C it won't stop because the watchdog timer is not built in. So maybe I'm using speeds that are too high. So this time I'm going to first zero it out. Yeah, I did stop. So let's run it again. I think I put it in the wrong place, right? I put it in X. And that's why it was doing that thing, because I'm forcing the robot to turn over. So Z is correct. Oh, I'm sorry. No. Z is correct. X is forward. Yeah, the speed is too high for it. So remember I told you that I thought I could run it at 0.4. So it's too much for it because yesterday I ran it in MATLAB. You saw that. So here's what I'm going to do. I'm going to first kill it by entering 0. I can't do it here because I have to launch again. And I want to show you something before the end of the class that I thought you should see today. We'll fix your problems, don't worry. But everybody understands that you have to zero the velocity out because the watchdog timer is missing. They haven't programmed it. You see that? The physics is causing it to stop over a distance. Because all that is built in. That's why it appears to be still moving and trying to stop. Okay, now, you can always reset the word by doing this. It snaps back to 0, 0, but you can't reset it to 4, 2 or any other coordinate. That's why I was trying to show you the raw service call, but we had that, it wasn't working. But please bear with me because I'm going to go back over this tomorrow, but I want to fast walk you through this. So first, I need to minimize this window, not minimize, but make it smaller because I want Arvis also to show up. So I'll be going through this again tomorrow, but I wanted you to get a quick look at it. I'm running a program called Arvis, which we'll get into the details of tomorrow. So Arvis is a spy on Gazebo. Gazebo is the actual simulation environment. It is the real world equivalent, right? But Arvis is spying on Gazebo. It's getting all the sensor values, it's plotting it out. Arvis kind of looks like Gazebo, but it's not Gazebo. It's a spy that's spying on Gazebo. It's picking up all the sensor data. The two are not the same. Now, the first thing is, I'm going to do this in rapid fashion because I'm going to go through it tomorrow anyway with you. You have to change that to get rid of this error, and then you have to add the robot to it. So for that, is not a good screen. Yeah, here. Ah. My blood pressure went up because I couldn't see that button. I'm going to change the background.
हाँ 2 से कितने जाना 2 सी मुझे
कैसे
फटाफट
हाँ?
I can't stay till live with a phone.
Oh, don't tell me I lost control. Oh, okay. I guess I can't do any color change. No, the color change it won't let me do here. Okay. We'll work with the black background. I also need to add the LiDAR. So, this robot is outfitted with a 360-degree LiDAR device. Now, what that is it has a LiDAR. You know what a LiDAR is? So a LiDAR sends out a ray, and then you get a return reflection. It sends out 360 rays because the LiDAR on the Turtlebot 3 is spaced at 1 degree apart. So 360 rays covers the entire field around the robot. 1 ray per degree. So that's typically how you pick up 3-dimensional objects. So to drive, you have to see 3-dimensional objects around you and avoid them, obviously. So let me just show you what the LiDAR will look like in under perfect circumstances. Today so many things are not working, then I'm not sure, but I'm going to give it a shot. So there's the laser topic, and I've got to choose scan. Now right now you don't see anything because remember we have an empty word. Okay, I can minimize this. I didn't want that. I don't like those spheres. So what happened to this thing? This is it right here. So the contrast here is not that great. I just tried this, just after lunch, and it worked on my machine. So let's see whether we can increase the size of that and make it 5. Nothing. Don't know why. The robot model is there, but I don't see anything. Unless it's my eyes, I can't see anything. So I tried this just after lunch on my machine, it worked. So for some reason it's not showing up. Status okay. Let's add it again. It doesn't even seem to be putting it there. I don't know, unless I can't see it. It's supposed to be here, right here. see if I can see it on my screen. Oh, I have to move the whole thing. No, I can't see it here anyway. So I'm going to have to fix it. We have a lot of fixes to do because it worked just a few hours ago. So I don't know what's going on. So essentially I was going to show you that RBiz displays the LiDAR hits on the obstacle. In the empty world, there's nothing to hit, right? So you won't get anything. So that's why I placed the cube just in front of the robot so that you could see it. But for some reason it's not showing up. So we'll try and fix the problem. Huh? It's working? No,
For them.
did they try it?
Did you try that? Okay.
It's not working?
No?
We will fix that. Okay. So I'll see you tomorrow.
Yes, yes.
We'll pick up from the point we got stuck. Okay.